Hello? Hello? Can you all hear me? Hello? Hello, ma'am? Okay, so I guess it's my turn. Hi everyone. So this is me, Irene Marcos. My God, where are they? So, okay. Hi everyone. So I am not receiving any messages from the chat, but let me start my presentation. So my research is all about deriving the and applying the distance formula through problem solving. And 1 second. Okay, so going back, my topic is all about deriving and applying the distance formula through problem solving. And the purpose behind this research is are to determine how students derive the distance formula using the Pythagorean, or what we call the Pythagoras theorem, and how they apply it by solving real life problems. Aside from that, this research will also show you the techniques or the different techniques and strategies used by the students to solve the problem, and some student teacher interaction that is also manifested in this research. The researcher collect data using report of the students, photos of the activity, learning activity, assessment, and reflections of the students. So, when I was in college, my teacher will always keep on telling us that life will only be good for only two things. And those are discovering mathematics and teaching mathematics. But nowadays, what happens is We usually focus more on teaching and forget about letting the students discover the true meaning of mathematics. So, in a typical classroom, what usually happens is that the teacher will give the formula of a distance formula, say, for example, and let the students find the distance between 2 points on a coordinate plane. The teacher will start on presenting the distance formula and let them or show how the students how to plug in numbers. However, this limits the thought of process of the students in terms of where the formula comes from. They always wonder about where, why, and how of attaining the distance formula. As a result, it is not quite clear where or nor students have a fully understanding of the distance formula. Students are not always encouraged to develop their ability to investigate relationship. So I usually sometimes in the class I know that we usually encounter this wherein students would have to tell you that where did you get that formula? What is the importance of that formula? And we actually don't want that to happen to us. So instead of just being bookish and just giving or spoon feeding your children and bombarding them with formula, why don't we teach through problem solving? So, in teaching through problem solving, it needs to be clearly distinguished from teaching problem solving. The word teaching through problem solving will always be different from teaching problem solving. In a lesson about problem solving, students might work on a problem and then share with the class how using one of these strategy helped them solve the problem. Other students can applaud, the student and the other students sit down and the lesson ends. That's how you teach problem solving. Now, these lessons are usually outside the main flow of the curriculum, and they are actually purposely independent of any curriculum. But when we say teaching through problem solving, the goal is for the students to learn precisely that mathematical idea that the curriculum calls for them to learn next. And teaching through problem solving approach, the teacher will be able to inculcate to the students the true meaning of mathematics through the real life and real world problems. So my research is actually focusing on students deriving the distance formula using the Pythagoras theorem through problem solving and the interaction between and among the students as well as the teachers, and as well as between the teacher and the students. So in problem solving, in problem solving, one finds the solution to a particular situation by a means which was not immediately obvious. A problem solving task is one that engages the learner in thinking about and developing in important mathematics they need to learn. According to Hybert, he have brought the problem solving approach for teaching and learning of mathematics with understanding to the fore when they state, we believe that if we want students to understand mathematics, it is more helpful for them to think of understanding as something that results from solving problems rather than something we can teach directly. So, with this, if we teach our students through problem solving, giving them the challenging problems to our students can trigger their interest and lead more to a meaningful learning. But when we teach through problem solving, does that mean that we just sit down? Of course not. we have to we have to see to it that we also facilitate our students in their learning, and see to it that we lead our students in discovering new ideas. So there are four problems, or there's the main statement of problem that I am dealing with. First is that, how did the students solve the problem? Second, what are the student teachers interactions? Third, what are the varied solutions and approaches of the students? And fourth, what are the students' perception? So let us see. Okay, as a researcher, I have collected my data from the New Kuwait Philippines International School in grade 10 class. And there are 30 students in this class. And a detailed lesson plan was utilized to teach the derivation and application of the distance formula. The lesson plan is actually designed for a discovery approach. So the lesson started with consolidating the prior knowledge of the students about Pythagoras' theorem and the coordinate system. So the teacher actually presented some questions about terms like coordinates, axis, what is a horizontal axis, what is a vertical axis, what does intersection mean, and what is an origin. So that was the review session. And it took about 5 minutes, and students were able to answer it properly. So the students were, at the beginning, after the review, the students were put into groups, and the students were put into groups of 5 and asked to mark various location landmarks on the map and discover to get from one place to another. So that's another activity that they have. Secondly, is that the teacher have posted a problem as a motivation. Then the whole class had a short discussion about the problem before start doing an activity. They read the problem and try to understand it better by making an illustration. Then the teacher grouped the students and let them answer the problem under her facilitation. So this is the problem. A lake is shown below. The island is located at 4, 5, coordinates 4 and 5. A boat travels in a straight line from coordinate 2, 0 to the island. How far does the boat travel? Round the answer to the nearest tenth. So in here, you would see that there are two boats. There's an island and a boat, and it is plot on a coordinate. So what did the students do here? So you would see here that the students were doing the activity, and in this picture, you would see that each one of them is actually assigned to a task. One doing the calculation, one who is drawing or illustrating, and then some who are giving their ideas according to what they have learned. So the class was actually divided into 2 to 4 members each, and each student was assigned to do a task in order for them to formulate their answer. So most of the groups started their work by plotting the points and then solving. So together they solved the problem with the teacher guiding and facilitating them. Here. So here are the varied solutions of my students. On the first part, you would see the student, on the first picture, the smallest one, you would see that the student just drew the Cartesian plane, and then after which just plotted the points and then connect it through a line. And in here, it is written that they just use a ruler to find the measurement of how far the boat traveled to the island. But on the second part, on the second picture, on the right side, they actually did or draw a right triangle. And in here, you would see that the right triangle, what the student did is that they've used their prior knowledge about distance between 2 points, not in terms of x and y. So first, the student find the distance between AB, which is 4 minus 2, absolute value of 4 minus 2. And then you see here AC, which is 5 minus 0, absolute value of 5 minus 0, 5. And then since they have a prior knowledge about Pythagorean theorem, what they did is that they find BC. So BC, we're in Pythagorean theorem, that is the hypotenuse. So it will be a squared equals b squared plus c squared. That's according to how they drew the figure. So that would be 5 squared plus 2 squared is 29. So a is the square root of 29. So it was said in the instruction that they have to round off their answers to the nearest tens, which they actually missed. But it is okay because they still have the same answer anyway. So square root of 29, which is roughly 5.39. Now, on the third picture, you would see here that it is actually from the same, almost the same as picture number 2. The only difference that the student did is that they had an explanation. So they put the formula of the Pythagorean theorem and they said like C is the hypotenuse, and to compute for the distance, get A and B first, then use the Pythagorean theorem to find the distance. So they actually explained it. In the first picture, by the way, the student put 5.3 as how they use it in the ruler. So students use different various way of solving a problem, but that's okay. Like what I always keep on telling my students, there are always different way of solving a problem. What you have to do is that make sure that you arrive to the same answer. So I have in here also the conversation between the teacher and the students. So after the teacher checked and reviewed the solutions and answers of the students, the teacher asked the students questions that will lead them to the derivation of the distance formula. So teacher said that, what was the first thing you did when you were finding the distance from an island to another island where the boat comes from? So students said, since the location of an island is on coordinates, then they drew first the point in the coordinate plane, and then followed by getting the distance between 2 points according to x's only, and then according to y's, and then applying the Pythagorean theorem. Next, aside from that, uh, they find the distance because it's the hypotenuse. They find the distance using the Pythagorean theorem. And then the teacher asked if you actually immediately use the Pythagorean theorem. And then the student said no, they didn't use the Pythagorean theorem immediately. Instead, they had to find first the measurement of the legs through the distance formula of 2 points in one coordinate. So that would be the absolute value of x1 minus x2, as we all know. Now, after that, the teacher presented another coordinate plane. So, assuming that you have the point A as x1 and y1, and point B as x2 and y2, what would be the distance? So, the student said that they have to find first the distance between A to the end vertex of the right angle through the absolute value of y2 minus y1, and the distance of B to the vertex of the right angle, which is x2 y2. And then after that, the teacher marked the illustration, which is this one. So what happened now is that you will have here x2 minus x1, that's the distance from the B to the endpoint of the x-axis. I mean, not the endpoint of the x-axis, endpoint of the right angle. And then you have A to the endpoint of the right angle, or the vertex of the right angle, as y2 minus y1. So when they have solved that, they went back to the previous problem, which is the island and the boat. So they applied that, assuming that 2, 0 is actually x1 and y1, and 4, 5 is actually x2 and y2. So applying the distance formula, say assuming d is a distance, they take the square root of x of 2 minus x of 1 quantity squared plus y of 2 minus y of 1 quantity squared. And see, they all arrive to the same answer. Square root of 29 or roughly 5.38. And then the teacher gave an activity. At the end of the lesson, the teacher asked her students to give some response. And in this response, you would see that some of the students have said that the lesson for them is kind of hard, but nonetheless, they have enjoyed the activity. And they think that they are going to use this distance formula in terms of individual jobs involving distance computations, which is kind of good. Next, in conclusion, mathematics is one subject that pervades life at any age and in any circumstance. Thus, its value goes beyond the classroom and the school. We should teach our children to value mathematics not only inside the classroom just to get good grades, but also outside the classroom for them to apply the lesson or the concept that they have learned in real life situation. The result of this research actually illustrates an effective way of learning mathematics through problem solving. If students are able to communicate their thoughts and be able to socialize while learning, then the results of the learning will be more productive. And likewise, consistent questions or the art of questioning coming from the teacher will stimulate a good interaction between the teacher and the students. Moreover, students who enjoy what they are doing tends to understand mathematical concepts a lot better than those who do not. I remember one of the video that Amy have told us that we have to watch, or I mean, we have to let our students learn while they are playing and while they are enjoying. So I guess we have to give that opportunity to to our kids, to our students. So this research eventually will let you understand on how to let your students learn more and perform through creative and analytical and critical thinking manner. So that's it. Thank you.